This is an electron diffraction tube. It's a standard piece of equipment that we can use to show the wave behaviour of electrons. Now, it's not used as widely as it might be, but let me show you how safe and straightforward it can be to use. This bit here is an evacuated bulb, and the biggest risk of using this equipment is probably that you might break this if you don't handle it with enough care. At this end, we've got an electron gun, a heated filament which releases electrons, which are attracted to the anode here, where they pass through a small hole and create a narrow beam, which travels across the tube and strikes the fluorescent screen here. Now in this tube we've got a thin sheet of graphite here in the path of the electrons, and it's this which causes the electrons to be diffracted. And in order to use this, we need an extra high tension or EHT voltage supply. This is the power supply I use. It's got a high voltage supply here for the anode and a separate low voltage supply here for the cathode. We're essentially connecting two circuits. Now the reason why it's safe is that there's a high value resistor in series with the high voltage supply here, so the maximum current you can get out of it is not really big enough to do you any harm. Now before doing anything else, I make sure that all the switches are set to off and the voltage controls are set to 0. I then connect the 0 of the high voltage supply to the earth and the 0 of the low voltage supply to the same earth. Next, I connect the outputs of the low voltage supply to a couple of wires, so I'm ready to connect the cathode. And next I'll plug in the anode, for which I use these shrouded connectors, and that's so that there aren't any exposed bits of metal at high voltage. So that's the thing wired up and it's ready to turn on now. And I'm going to start by switching on the cathode, which takes a little while to warm up, but there you go, you can see it starting to glow now, which means you can turn on the high voltage supply. And I'm going to turn that up to about 3000 volts. Now, what I hope you can see is a green dot surrounded by fainter concentric green circles. And that's a diffraction pattern that's produced as the electrons fly through the graphite. Now, you can increase the energy of the electrons by increasing the voltage. You can see that's changed the diffraction pattern. The rings are closer together. And that's because at increased energies, the electrons have a shorter wavelength and they're diffracted less by the graphite. There's one more thing you might want to do with this apparatus, and that's to convince your students that the pattern is genuinely produced by electrons, that is, charged particles, and not by a beam of light. And to do that, you use a magnet. And if you bring that close to the beam, you can see that it deflects the image on the screen. And that certainly wouldn't be happening if it was being produced by a beam of light. Now, once you're done with the apparatus, obviously you turn it off, but it's best to wait a few minutes before disconnecting because it can take a while for the high voltage to die down to 0.